Hi, my name's Allison, and the title of today's talk is Creating Macros for SMEC. Alright, today I'm going to take you on a journey, my journey, from modifying one existing 12D macro to the creation of a powerful suite of over 70 macros. Our macros for this day have recorded over 153,000 uses with an estimated savings of 26,000 hours and $1.86 million. Today, I'll identify a gateway into 12D macros. We'll look at the role a business case plays in the process and demonstrating how you can use this thinking to help make changes in your business. We'll see the power in creating metrics and the importance of creating measurable data. And finally, we'll see the fruits of labour, the rewards and outcomes. So sit back and relax, get excited, and let's try and save some time and money. All right, firstly, I'd like to thank 12D for inviting me to speak today. My name's Allison, and I'm a civil engineer at SMEC. I've been at SMEC from my penultimate year at the University of Melbourne until this day. I graduated with a Bachelor of Engineering and a Bachelor of Commerce. The reason I tell you this is to highlight my lack of professional programming training. My current role is the Victorian Digital Engineering Practice Lead for SMEC. Previously, I've worked in our urban engineering team through a variety of roles, from an undergraduate designer through to a project manager, as well as a systems developer and a technology practice lead. Over the last 6 years, I've been facilitating SMEC's 12D development and capabilities with an emphasis on systems efficiency and enhancing the team's capabilities. All right, so let's get into some macros. So firstly, some background information. What is a 12D macro? In short, a macro is a program that can run in 12D. Sometimes they have user interfaces where a designer can interact with them, and other times it's just code that runs in the background. In a literal sense, a macro is a programming or a code file, a 40M. This is written in programs as simple as Notepad. And these files can be read by humans. So you can see that example on the right. This is an example of a simple macro which was written back in the day by, I think it was Alan Gray. I think it was just to pull off some changes. So in order to run or use a program, it needs to get compiled into a 40O. Compiling pulls in all of the libraries and puts it into a state ready to be read by 12D. And now 12D can run it. All right, what is the value of a macro? Macros remove the limitations of panels or commands created by 12D. It allows you to access the database, which stores all of the model's data. It allows for the creation of custom panels and helps users access, create, and modify attributes and properties at all levels. It also allows for users to run a series of commands on specific elements, vertices, or segments. But overall, it just gives you more power. It gives the person using the machine more power. All right, so how did I get hooked? How did I get into it? It was quite simple, really. We're the macro that created lot levels. Lot levels are placed on plans to show finishing existing surface levels, particularly on a subdivision's property boundary. The macro gets each property boundary string and returns a piece of text based on the tin's height. The issue we're having was that the name of the bits of text that were coming out were 1057 and 1047, something that didn't really make any sense. So I wanted to change it into FS or EX, something that everyone could understand. So I looked into our user menu, found where the 40O lived, went into the folder and found it. However, the 40O, I opened it up and couldn't read it. I had no idea what it was about. However, I did open the 40M, what I mentioned before, readable by humans. The 40M file was there with the same name, and I opened up in Notepad, and sure enough, I could read it. And funnily enough, the bit I wanted to edit was right at the top, the string names and the text name. So I made the quick change, changed the numbers to the letters that I wanted, went back into 12D, found that compile run command that you can see there, and sure enough, that was it. Done. Pretty simple, quick change, but then I wasn't really done there. I wanted to, I guess, improve this macro even further. One thing that had always annoyed me was having to, I guess, rotate the text. Why couldn't the text come out rotated based off the string it was created from? So some further digging and finding the 12D programming language guide, and I had a pretty good idea of what I had to do. So I spent some time figuring out how to read some properties and set the angles of text, and sure enough, within a couple of hours, I'd figured it out. And we can now have a look at the before and after. So the before is on the left side picture, the right's on the after. So the existing workflow was run the macro, which produces all text at a 45-degree angle. The drafter would then spend hours, up to hours, realigning this text with the property boundaries. My customization, spent a couple of hours programming the macro to rotate the text parallel or perpendicular to the lines, and the new workflow was as simple as just run the macro. I immediately recognised that the power of what I'd done. I just saved SMEC hours of drafting, but for every package for the rest of the time. Imagine what I could do if I knew what I was doing. So it was time to learn. So my background, as I said, I'm a self-taught programmer with minimal training. Did a bit of basic and visual basic at high school and a touch of MATLAB at university. However, I did have a good understanding of how computers works, and I'm genuinely interested in learning new things. So after editing this existing macro, I thought there'd be some value in attending the one-day course. The course was actually run by Dr. Lee Gregory himself and was just attended by me and Matt Stevens, who now actually runs it here in Melbourne. The course was fantastic. It gave me the opportunity to ask questions and get a background on how everything works and why it was the way it was. It was a little defeating though, walking in to find out that the entire course notes that we're going to be using and all of the macros, the example macros, could actually be found in the 12D model macro manual right at the back. So I already had all the material that I needed, but yeah, it was fantastic to be able to ask questions and get that, get some background information. Following on from the course, learning how to program and creating programs was just going to be down to hard work and a hell of a lot of trial and error. For me, I just keep trying to edit something until it compiles. If it compiles, for me, it's a win. All right, so if you wanted to get into it, here's some useful resources. So first of all, the 12D model macro manual can be found via the help menu, as seen on that previous slide. This PDF should have all of the information, structures, and macro functions in it. The 12D forum is another fantastic resource. Even if you don't care about macros, the forum has answers to nearly all problems people have faced in 12D over the last few decades. So unless you're on the cutting edge, I'm sure most of your questions have been answered on here. The hardest part of the forum is figuring out how the search function works. By far the most helpful tool is the Notepad++ setup, which you can see the top right. I don't know who deserves the credit for creating it, but the coloring and function prompts are awesome. It saves so much time picking up mistakes, and you can find this, funnily enough, on the 12D forum. This setup also comes with it also lets you compile a macro without having to touch 12D, and it actually tells you what your mistakes are if you're trying to compile it and it doesn't work. So this is a huge advantage when it comes to debugging. It obviously speeds up the process a lot more. The last resource I thought I'd mention was the 12D. The 12D ships with macros. So it comes with 542 compiled macros, which a lot of the panels that are built into all of the menus. However, it does come with 45 uncompiled ones. And as I've mentioned before, I do recommend starting editing an existing macro rather than to write from a blank screen. It's much, I guess, much nicer to do it that way. So now I'll get into some of the process enhancements or some of the ways that we do it here at SMEC. So first I'll run you through a testing structure that at SMEC we put into place to help our macro development process. So firstly, version control. Version control is extremely important when writing macros. These are files that can be thousands of lines of code, and every single character normally matters. You always need to have a backup before your writing session just to make sure, if something goes wrong, that you've got that backup. Access to information is just as important as version control, as important as version control. And we need to limit people's access to this information. Time spent on development is time that could have been spent on projects. And the last thing we want is intellectual property to walk out the door when the next person leaves. So limiting who has access to this uncompiled code, it's very important. Synergy happened to be the perfect solution to address both of these issues. Back in the day, we didn't have Synergy when we first started doing this. It was a nightmare to do it just on a standard server. So with Synergy, we could quickly limit who had access to the development folders without having to talk to our IT department, which is a massive win. Secondly, we could use the standard check-in, check-out feature to ensure we had daily backups as well as your long-term history. Another thing that sort of helped our process is we wanted to look at our feedback loops. So feedback loops are extremely important in programming. Reducing the length of a loop can allow for learning and adjustments to take place much quicker. One of the feedback loops that we use is in the testing of macros. Considering that we would test every couple of minutes at times, any savings of time here was going to reap instant rewards. So the far left, that's using the default panel where you have to, it's slow. Especially we have to browse for the macro each time. So you have to open up the panel, browse for the macro, go through all your folders, find the one, click select, then click run. Pretty slow. Take you about 10 to 30 seconds. Dragging and dropping, obviously much quicker, the middle panel, but it does get a bit clunky having to manage your panels around the screen just so you can drag and drop each time. So we came up with this panel, the one on the right. Having this panel open would allow us to see all of the compiled macros in our development folder. This allowed for a one-click run of the latest compiled version of each macro. It also lets us look at what other people are working on, and we can test out their latest and greatest. All right, another feedback loop we use is user feedback. So for us, it's extremely important to receive open and honest feedback from our users. So we built this feedback button, the one highlighted there in yellow, into nearly every panel that we create. The feedback button calls another macro, the one below, where the user can fill in information as they like. So they can change the topic if it doesn't actually relate back to that initial macro that they were working on. They can tick an anonymous button in case they're providing some negative feedback and they don't want to, I guess, hear about it or get any blowback. And so when they click send, the feedback is sent to a CSV file where the development team can look at it and address the issue. So that's enough about our process. So far it looks like smooth sailing, Josh having fun, doing what he likes, with no obstacles in the way. And this is far from the truth. SMEC is a consultancy after all. We, like most of you, make money on billable hours. The problem I faced was getting time to work on it. So how could I do it? Create macros in real time on projects to prove their benefit and value? I could ask for time or generate a business case to prove its worth. The answer was D, all of the above. I firstly created macros that would provide benefits on current projects that I was involved with. And once I had enough programs in the bank, I decided it was time for a business case. Rather than having to explain or demonstrate numerous times the value that these programs have, I thought a business case would provide managers higher up the line with information required to approve time spent improving the system for everybody. All right, the problem we immediately faced was all of my data was qualitative. It was all subjective, descriptive, all words, effectively hearsay. This may be a generalization, but in my experience, engineers love quantitative data. We love numbers, graphs, and objective figures that we can see and not have to read. Every time we looked at the business case, one issue stood out. There were no numbers, no data, nothing that was really backing up what we were saying. The solution was to create a metric, something that was measurable, that we could make predictions off and calculations from, and something that could be analysed. So we built a logging feature that could be added to all of the macros. Every time a macro was used or clicked, it would log the time, the date, macro name, the project name, as well as the user's identification. We also estimated how much time each macro saved with every click. This allowed us to create a time and cost savings metric shown by that equation. So usage times by the time saved per click times by DLC, or like your labor cost, would equal savings. Secondary to this feature, the logging code actually helped lock down our intellectual property to ensure that only SMEC people could use the tools that we created. As previously mentioned, the last thing you want is people trying to take hard work on the way out the door. Macros can easily be locked to dongles, usernames, user domains, files, or servers, and that's just to name a few. We also built in a flagging system to let us know when people attempt to run our macros without the acceptable credentials, i.e. they had stolen them. And we have actually recovered over, I think, half a dozen uses where people have tried to use them at other companies. Within 3 months, we had 750 uses of the macros, and we'd estimated that we'd save roughly $24,000. Adding this data to the business case saw it was actually successful, and I attained 2 months of full-time development for our urban engineering team. So the first 3 months, we started building, and here are some of the ones that we created. So this one's called tin control. It allows you to turn off the tins pretty quickly. So tin design going on and off there. It also allows you to turn each tin's strings on and off at the click of a button. Something that some people do all the time. I do it all the time. Turn them on, turn them off. And it also allows you to recalc the tin with a single button click. It's a fairly simple macro that doesn't really save stacks of time. It was just more the nagging of having to have that edit the tin panel open up, taking up a fair bit of real estate, or having to browse through menus to turn strings on and off. Another one we developed was this PC convey and hydraulic analysis. This macro here helps us analyze the flow through each cross-section of a road or a channel. It utilizes the Manning's open channel flow calculation to determine flow depth, velocity, and other attributes that we want to look at. There's a requirement in Victorian subdivision roads to check critical cross-sections for their, their flows and their freeboards. This macro brings all of the cross-sections in from a model. Then you can then enter a Q100 flow, or whatever the flow is for each critical catchment or cross-section, and we can click run. The outputs provide us with all of the required information to check what we have to check, as well as creating water surface level tins and freeboard tins. So on that cross-section below, the yellow line is actually the water surface tin, and the blue one is our freeboard tin, which we might check against our lot levels. This macro allows it also allows you to output a native PC convey file where the critical cross sections can be opened, and we can create polished PDF outputs that we submit to council. And finally, the first couple of months, we created drainage control. It's probably one of the best creations we've come up with, and this GIF shows us, I guess, the different panels. So it does run through it pretty quickly, so just keep your eye out, but I'll start talking. So the first tab on the left, which it'll come back to in a second, is the drainage network editor settings. So these are the key ones that we want to check just to make sure that our designers are using the right settings, the right rainfall file. We'll get there in a second. The next tab we'll see will be the create one. On the create panel, we can create, so this is the network editor settings. Next one's the create panel. This is where we can create strings, we can create catchments and even output polygons. This is a pipe editor where we can actually see all of the pipe attributes that we like to look at, and we can see all of the locked strings and the invert levels and all of the overrides from the network editor. And we've got a pit editor as well to see all of the pits, the types, and we can apply any changes and add remarks to pits. And finally, we've got the output one where we can output long sections, plans, IFC, 12DAs. We can do all of our quantities with crush rock backfill, extra over for when you need crush rock in your road reserves, as well as a pit schedule. This macro saves us a hell of a lot of time having everything that we want to edit in one location, all of our outputs in one location, and all of our creation of strings in one location. This was actually one of the macros that helped us win the 2016 Innovation Awards. All right, so as time progressed, our logs just kept logging and usage started to increase. The teams grew and other functions within SMEC started to adopt our tools. Microsoft Excel was no longer cutting it with regards to our data analysis, so we linked the tables with Microsoft Power BI. Power BI lets us analyze the data with a greater level of control and allows you to drill into your information. We could now spot trends on specific macros and to see whether they were getting used at all. It let us identify where potential usability issues were, if people didn't understand how it worked. It also let us see who in the team is or isn't using specific tools. We could then go and talk to people and ask them why they weren't using it. We can also see which macros create the greatest value and which ones maybe just are nice to have or used by a few. For example, the data shown here is from our sewer control outputs button. We can see how it has trended up over time, and we can see that it's the 6th largest contributor based on usage, and we can see a count of how often different people have used it down that bottom left corner. Overall, it's changed how we've thought about each macro before we even spend time creating them. What I mean by this is we begin to do miniature business cases on every macro before we even type a single line of code. It's because it's become obvious to us whether we should or shouldn't proceed with an idea because there may not be enough value in it. All right, so fast forward 6 years, and as I mentioned, the results speak for themselves. Over this time, 70 plus programs, 153,000 uses, 26,000 hours of time saved, and $1.86 million in labour costs. And next up, I'll get into some of the other outcomes. Thanks to the business case thinking and thanks to the log data, here's some of the other outcomes. So first of all, we got the gift of time. We'd won over management, and now we have the green light to get creative. In 2016, we won the 12D Innovation Awards, the overall prize for our drainage and sewer developments. We've also had 4 successful business cases approved within SMEC at a variety of levels, including 2 by our executive committee. It's significantly contributed to 2 personal promotions to myself, and it allowed me to get a part-time role creating to help manage and facilitate everything 12D at SMEC. And lastly, we've got some pretty happy management. All right, and here's some of the most recent additions that we've continued to develop. So lately our tools have been to help checkers work and live in the digital engineering model. So here we've produced cross sections in 3D. This macro allows a modeler to take any cross section, like cross section model, and place its cross section drawings in its real world coordinates. The macro allows for the selection of a cross-section model to have its outputs located, right where we want it, right on the plan, or we can actually offset it, maybe off 40 meters off to the right, just so we can reference it. So in this one, the modeler can select from the following output parameters. You can choose a cross-section, you can choose a rise if you want to offset it up or below. It could, as I mentioned, a horizontal shift. It also gives them the option to rotate the cross sections perpendicular to the plan if you're doing it in plan view. And yeah, there's the tick box if you want to get vertical or plan view cross sections. Pretty much this macro allows for design checkers to view these cross section information exactly like next to where that change is in the real world coordinates, and allows you to actually bring this information into a BIM model. Hopefully, this can help one day to remove the need to actually output these as cross-section drawings. Another recent addition we've created is this drainage drafting in 3D. This macro allows a modeler to take any network, any pipe or pit attribute from a water string and plot them in real-world coordinates, like similar to a long section. So, like a PPF, the modeler can select what attributes that they want to see. You can pick 4 different locations of where you want to put the text, whether it be relative to the center of the pit lid, at the upstream or downstream inverts, or the mid-pipe invert. User can also select the text size, offset, your typical things, the rise, the color, pre-text, post-text, and a number of decimal places. Again, this macro allows the design checkers to view information usually found on the drainage long section in a BIM model. And as I said, hopefully this can help the quest to removing the need for drainage long section drawings, and hopefully it's another step in the right direction to removing drawing stats altogether, maybe one day. All right, so I'll wrap it up now. I'd like to double back and emphasize, I guess, the importance of business case thinking. Without this focus, without creating a metric, we never get the time to work. We don't get the time to work on enhancing our capabilities. These 200 lines of code have provided me with numerous opportunities at SMEC, and I'll keep striving to improve us as a business. I'd like to thank you all for listening, and thank you to 12D again for putting on this exceptional technical forum. It's been an absolute privilege to be presenting in front of you all today. Thank you.